Hello, Bridge. How are you doing? This is week 4, and it is the first assignment. It is 4.1. I have a bridge of the day for you. Any guesses? It is the Pamban Bridge in India. Apparently that's the Indian Ocean. Pamban Bridge in India. Pretty cool, pretty cool. Nice sunset. All right. So we have been talking about logarithms. Now we can go from exponential form to logarithm form. And we have a way to evaluate logarithms using the change of base formula, or, maybe we have some of our little exponentials memorized in our heads. We're going to now use them to solve exponential equations. I wrote up some quick steps that are just going to help you if you want to write those down or take a screenshot of them. First, you're going to solve the equation. So I'm going to give you like an exponential equation. I'm going to have you solve the equation and tell us just a very simple exponential. And when I say simple or basic or an easy one, I'm really talking about, is it in the form like a to the power b equals c, right? I'm not multiplying by 4 on the outside. I'm not adding 2 at the end or anything. It's just very simple. I have a base, it's raised to a power, and it's equal to some number, right? That's what I'm going to be calling like simple. So our goal is to get there. Once we are there, then we can write the exponential equation as a logarithm equation, all right? So this exponential here as a logarithm would be, okay, well, I have a base of a, so log base a of c, right, of my answer, is equal to this exponent b. I have to raise a to the power b in order to get c, right? So that's going back and forth between our logarithm and exponential equation. And then step 4 is evaluate this logarithm. So if you were given some numbers in here, you could use the change of base formula and see what that is equal to, right? That's what the whole last week was about. And then step 4, finish solving if necessary. So we're going to jump into some examples right now. 9, so here's an exponential equation. 9 to the power of x equals 89. This is an exponential equation because 9 is raised to the power of a variable, and we want to solve for that variable. So my first step was finish solving until it's into a very simple exponential equation. And just by looking at this one here, it is a simple exponential equation. It is just a base raised to a power equal to a number, right? That's what I'm calling simple equations and a basic exponential equation. Now I can take this and write it as a logarithm equation. So this as a logarithm equation would be log base 9 of 89 equals x. Again, I have to raise 9 to the power of x in order to get 89. So now I can evaluate this side, because that was the next step, was evaluate that logarithm. Evaluating that logarithm, well, I know that 9 raised to any power, like a nice even power or whatever, it's not going to be 89. It's going to be some decimal. So I'm going to have to use the change of base formula here. So using my change of base formula, I'm going to pick a new base, and we're going to probably pick base of 10, so that works with the calculators very well. So log base 10 of 89 divided by log base, again, I picked a new base of 10 of 9. Again, 9 was like our original base, equals x. Again, these two are the exact same thing. That's why I'm able to write it like that. And now this is something that I can evaluate. So in my calculator, I'm going to plug in log base 10 of 89, or just log 89, close parentheses, divided by log 9, close parentheses. And that's going to give us a really long decimal. So x is roughly, again, after I used my calculator, x is roughly 2.0428. So I'm just going to say, I'm going to round it off. It's about 2.04. All right. So there we go. And if I wanted to check, I could raise 9 to the power of 2.04 and see if I get 89. And you can check it on your calculator if you want. And if you think about it, I know that 9 raised to the second power is 81. So if I had to raise it to the power of something to get 89, it's going to be just a tad above 2. So this does check out, all right? Let's go on to another one. That was a very simple, basic exponential one. Now we're going to move to something that's going to be a little bit more different. So here with this one, I see that I have 4 times 3 to the power of x equals 64. So this is not a very simple or basic exponential equation because I have that 4 on the outside, right? If I can get rid of that 4 somehow, then it'll be much easier to write this in logarithm form. So to get rid of the 4, since it's being multiplied, I'm going to divide by 4 on both sides. So that's going to cancel out, and I'm going to be left with 3 to the power of x equals 16. All right, now that is our very basic exponential equation. I can write this now in logarithm form. So in logarithm form, that's going to be log base 3 of 16 equals x. I'm going to bring that change of base formula back, and I'm going to estimate this. So I'm going to say log base 10 of 16 divided by log base 10 of 3 is equal to x. And then just typing that into my calculator as log 16 divided by log 3, I'm going to get x is roughly 2.5237. All right, and if you want to round that off, let's just go to 2 decimal places, 2.52. Okay, so there we go with that one. Again, we're just going to keep going through these here. So here's my next one, 2 raised to the power of x plus 30 equals 38. Again, this isn't a simple equation or a simple exponential equation because I have that plus 30 on the outside. Once I get rid of that, then I'll be able to write it in I'll be able to write it in logarithm form. So to get rid of that plus 30, I'm going to minus 30 from both sides. And that gets me 2 to the power of x equals 8. If I write this change of base formula, I could say, oh my gosh. If I write this in logarithm form, I'm going to get log base 2 of 8 equals x. And then I can say, can I use my change of base formula here? Or you could just say, well, what power do I need to raise 2 to in order to get 8? Again, you could use your change of base formula here, or I can recognize that I need to raise 2 to the 3rd power in order to get 8. So x has to be equal to 3. Again, if you want to check that on your calculator, you could do log base 10 of 8 divided by log base 10 of 2. You will get 3. There we go. Okay, that one was a simple one. Again, from from right here and from right here, I was able to recognize that, well, x has to be equal to 3. That's one that I have memorized. 2 to the 3rd power is equal to 8. All right. I got a couple more. Stick with me here. You're doing great. 1/3 times 3 to the power of x plus 1 equals 28. So we're going to just keep solving this like it's a regular equation, right? I'm going to treat this as like my variable until I can get down to this very simple equation. So first I'm going to follow the same steps as solving equations. I'm going to minus 1 from both sides. That's going to leave me with 1/3, okay, because that cancels out. So 1/3 times 3 to the power of x equals 27. And then to get rid of this 1/3, because that 1/3 is being multiplied, you could divide by 1/3 on both sides, or I'm going to multiply by 3 on both sides, because 3 and 1/3 are what we call multiplicative inverses, so they're going to cancel each other out. So multiplying by 3 on both sides, all right, that 3 and the 1/3 cancels out, and I'm just left with this 3 to the power of x equals 27 times 3. 27 times 3, that's going to get you 81. From right here, I can recognize, okay, I kind of have memorized that 3 to the 4th power equals 81, so I'm going to guess that 3 to the 4th power equals 81, or excuse me, that x equals 4. Again, if you want to use your change of base formula, let's keep going doing this. So log, I'm going to write this in logarithm form, so log base 3 of 81 equals x. Using my change of base, so I'm going to pick a new base of 10, log base 10 of 81 divided by log base 10 of 3 equals x, and if you plug that into your calculator, it does give you that x equals 4. Okay, I think I have one more that's a little bit different, okay, 2 to the power of x minus 3 equals 512. The difference between the other ones and this one is that if you look at our exponent, now we have a little bit more in our exponent that we're dealing with here. So I'm just going to keep treating it like the regular exponential equations that we've solved. I mean, it's a simple exponential equation, right? There's nothing that I'm multiplying on the outside. There's nothing that I'm adding or subtracting on the outside either. So I'm just going to go and write this entire thing in logarithm form. Again, treating this entire thing here as your exponent, right? So log, I have a base of 2. So log base 2 of 512 equals my exponent. And my entire exponent is x minus 3. So I'm going to evaluate this side. What power do I need to raise 2 to in order to get 512? So log base 10, I'm going to use change of base formula, pick a new base of 10. Log base 10 of 512 divided by log base 10 of 2 equals x minus 3. You plug that into your calculator, this left-hand side, and you're going to get 9. So I need to raise 2 to the 9th power to get 512. So 9 equals x minus, 9 equals x minus 3. And then to just solve, this is the last step where we just add 3 to both sides. Okay? And then I'm going to get that x equals 12. All right. So the difference between that one, again, was there was a little bit more in our exponent, which means we just needed to take that extra step here and finish solving for x. All right? I think we're doing all right with these. Please let me know if you have any questions. There are going to be some on the assignment that are very similar to this again. I'm just gonna kind of zoom up on this if you need those instructions. Otherwise, I'm gonna say go team. You guys are rocking it. Keep doing what you're doing. Let me know if you have any questions. Fantastic. Adios.